Okay, so compound interest versus annuities. What's the difference? Well, compound interest is a lump sum of money. I'm just going to fix this screen here. So if you remember compound interest, we had a lump sum of money we called P, and that amount had interest added to it. Okay, and that was our formula. So the thing with compound interest, you only put money in the bank once, and then that money just sits there and earns interest. So it does accumulate, but you're only putting money in the bank once. An annuity is where we have regular payments or deposits. So regular payments if it's a loan, or deposits if you're trying to save money. Okay, so a payment might be a car loan, right? Maybe you're paying it every month, or a deposit might be an RRSP, right? A registered retirement savings plan where you're putting in a set amount of money every month. Okay, so a difference between annuity is that you're putting money in more than once. You're putting money in every deposit. Okay, so if you think about, let's say you put in $100 a month for 6 months. So you put in $100 6 times. Let's say 5 times. So let's say I put in $100 5 times. This first $100 you put in the bank is going to earn the most interest because it's sitting in the bank the longest. Right? So this first $100 has been sitting in the bank for 5 months. This second $100 is sitting in the bank for 4 months. The third $100 is sitting in the bank for 3 months, 2 months, and this one's only sitting in the bank for 1 month. So this one earns the least amount of interest. So with annuities, you're kind of getting a double whammy because not only are you earning interest, but you're also adding to that amount on top of that. So you're making more money, okay? So the definition, this is the formula. Oops, went one too far ahead. So the definition is a series of equal payments or deposits paid at regular intervals, so that's important, regular intervals, over a fixed period of time. Commonly found in savings and loans, examples are mortgages, car payments, retirement plans. Okay? When the deposit is made at the end of each month or in time interval, it's called an ordinary annuity, and then the amount at the end is the future value. Okay? So this is the formula. So you'll notice it looks a bit similar to compound interest. You've got the 1 plus I to the n, like you do in compound interest, but you have this R. So R is your regular payment or deposit. So that's different. A is the end amount, I is the interest rate, and N is the number of compounding periods. Okay? So it's a little bit different formula. So let's look at this question. So you are going to deposit every month, $100 every month for 4 years, and it pays 6%. So we're going to write out the formula. Okay, so R is the regular deposit that you are putting in the bank. Okay, so that is your $100. The interest rate is 6%, so we write that as a decimal. And then don't forget that we have to divide the 6% by how often you are compounding it. So that is compounded monthly, so we're going to divide it by 12. And then N is monthly, so 12 times a year for 4 years. So N is going to be 48. So remember, those are the two numbers that we want to make sure we get correct. Put that there. So this is power of 48. And then this is all over the 6% divided by 12. Okay, so it's up to you how you put it into the calculator. You can do the bracket first. You can do it one step at a time. You can type it all in. 0.06 divided by 12 is 0.005, and then add the 1. That's going to be to the power of 48 minus 1 over 0.05. So it might be easier to do those calculations first. So I'm going to do this big bracket first and then multiply by 100. So we'll type that all in, and the final result is $5,499.78. So what does that mean? B says how much interest has the annuity earned. So you did not earn $5,409.78 interest. Okay, the interest earned. So let's think about what we put in. So we deposited $100 every month for 4 years. So we deposited $100 48 times, right? That was our money. Okay, so we deposited $4,800. We earned $5,409. So the interest is the difference between the amount that we ended with, subtract the amount that we deposited out of our own pocket. And so you've actually earned $1,609.78. So you're going to subtract the difference. Sorry, not 16, 609. A little bit extra money there. So the difference between what you end up with and what you deposited is going to tell you how much interest that you earned. Okay? So it's very similar to compound, it's just a little bit different formula. Okay, so here's a few questions from the back in the practice questions. So I'll just do A and B, and then you can do C and D. So in A, we are depositing $3,000. I'll just write the formula out here. So $3,000, and the interest rate is 7%. It is compounded annually, so divided by 1 is not going to make any difference. So compounded annually. And then N is annually, so once a year for 10 years. So N is 10. So then we just have to calculate that. So it's going to be 1.07 to the power of 10 minus 1 divided by 0.07, and then multiply that by 3,000. And you will end up with $41,449.34. And I might want to check and see if that's a reasonable amount, just to make sure I haven't made any mistakes. So I know I deposited $3,000 10 times. So I deposited $30,000. So 41,449 seems like a reasonable answer. I've earned, the interest earned is $11,449. So that seems like a reasonable answer. Okay, you don't want to have some crazy answer that doesn't make sense. Okay, let's do one more. So in part B, we are depositing $650 every 6 months, so that is semi-annually. All right, every 6 months and semi-annually are the same thing for 8 years at 9%. So we're depositing $650 at 9% compounded semi-annually, so divided by 2. And then N is semi-annually, twice a year for 8 years, I believe. Yep, 8 years, so 16. And then we'll have the I on the bottom again. And then we just have to type that into the calculator. Who is late? Brandon. Okay, so you might want to do it in steps, or perhaps you want to type it all in the calculator at once. So 1.09 divided by 2 is 1.045. That's going to be to the power 16. And then we'll just type that in. Let me grab my calculator. And so that works out to be times 650 is $14,767. Okay, so let's just see if that's a reasonable amount. I deposited $650 16 times. How much money is that? That is $10,400. So that seems like a reasonable amount, 14,000. Okay. You might be asked to find, instead of finding A, you might be asked to find R. So this one says you begin a savings program to have 12,000 after 4 years. So this is my end amount. This is my A. So we want 12,000 at the end. Okay, and we're looking for R. So the interest rate is given as 7.2%, and then that is compounded semi-annually, so we'll divide that by 2, and it's twice a year for 4 years, so N is 8. Okay, so I'm just going to simplify this bracket. So 1.036 to the power 8 minus 1. I'm just doing that little bit of calculation. And then I'm going to make that 1 decimal. It's just one way to do it. So I'm going to do this whole bracket and get one number. So I get 9.0839. And then since I want to find R, I need to divide. So we want to eliminate that there and divide it over here. Okay, so my payment is $1,321.02. So does that seem like a reasonable deposit? Well, again, I can check. I have to make that deposit 8 times. Right, I'm doing it twice a year for 4 years. So I'm going to multiply that by 8, and I get $10,568. So that seems reasonable. I deposited $10,568 of my own money, and at the end of 4 years, I had $12,000. So I've earned about $1,900 in interest. So that seems like a reasonable amount to deposit. Okay. One thing that you want to be able to identify is whether it is compound interest or annuity. Okay. So when you are looking to determine that, you are looking for the word every or each. That will tell me it's annuity because that tells me I'm making my deposit more than once. So if I see the word every month or each month, I know it's an annuity. Okay? If I don't see that, I know it's compound interest. So here, you make a deposit every 6 months. Okay, here, deposited every year, deposited every 6 months, for $1,450 every quarter, deposited every month. So you'll see that word every or each, meaning you're making more than one deposit, and that's the difference between compound interest and annuity. I know we looked at the graphing calculator the other day with compound interest. I couldn't find it today, so I'll make sure that I find that for the next lesson, because we can use a graphing calculator to solve these. I just couldn't find the one that I was looking for.